When biology meets silicon, could bacteria power our next computers? What if the most powerful computer in the world wasn't made of silicon chips, but living bacteria? Think about it for a second. Your next laptop, your smartphone, even supercomputers in research labs, what if they weren't powered by electricity alone but by living cells? Sounds like science fiction, right? Well, it's not. It's called biological computing, and it could change everything we know about technology. Welcome to the Christian Omeni Tech Channel, your trusted hub for cutting-edge tech insights, smart solutions, and future-forward innovation. If you're passionate about technology and want to stay ahead of the curve, you're in the right place. Subscribe now and join a growing community of thinkers, builders, and tech enthusiasts. Fresh content drops regularly, don't miss out. What exactly is biological computing? Most of us are familiar with the classic computer model: silicon chips, transistors, binary code, 1 second and 0 second, but imagine replacing these with DNA strands, proteins, and living cells. That's the concept behind biological computing. Instead of electrons moving through a circuit, you have biological molecules performing calculations. Why bacteria? Because bacteria are tiny, self-replicating, energy-efficient machines created by nature. They can store information in their DNA, respond to environmental signals, and even communicate with each other. This makes them ideal candidates for the next big leap in computing. Why do we need this? The problem with today's computers: modern computing faces three major challenges. 1. Energy consumption. Data centers powering AI models consume massive amounts of electricity. 2. Heat generation. High-performance chips overheat and require advanced cooling systems. 3. Physical limits. Moore's law is slowing down. We can't keep making silicon transistors smaller forever. Biological computing offers a radical solution: energy efficiency. Bacteria run on natural processes. Scalability. They can self-replicate, reducing manufacturing costs. Eco-friendly. No heavy metals, no silicon waste, just living systems. How does bacteria-based computing work? Scientists are engineering bacteria with synthetic DNA circuits. These circuits act like logic gates, the same building blocks used in digital computers. Here's a simple breakdown. In a normal computer, 0 equals off, 1 equals on. In a bacterial computer, gene on equals 1, gene off equals 0. Researchers can program bacteria using CRISPR technology to perform tasks like mathematical calculations. Data storage: 1 gram of DNA can store 215 petabytes of data. Logical operations like and or not gates inside living cells. Harvard Swiss Institute created programmable bacteria that can record information into their DNA like a biological hard drive. MIT researchers built bacterial circuits that respond to chemical signals, effectively acting as biological processors. Imagine a small test tube of engineered bacteria that can detect toxins in water and send a signal to your phone, calculate solutions for complex equations at the molecular level, store centuries of data in a few drops of liquid. Future predictions: where is this headed? By 2035, we could see hybrid computers, combining silicon processors with biological modules for ultra-efficient performance. Medical applications: bacterial computers in your body monitoring health and releasing drugs when needed. Biological AI: neural networks that operate on biological neurons instead of artificial ones. Energy-efficient data storage: whole data centers replaced by biostorage solutions. Big tech companies like IBM, Microsoft, and Google are already investing in DNA storage and synthetic biology, making it relatable. Okay, let's bring this home. What if your phone battery lasted months because part of its processing was biological? What if hospitals used bacteria-based chips to diagnose diseases instantly inside your body? Or what if your entire music library, all those thousands of songs, fit in a single DNA strand smaller than a grain of sand? This isn't science fiction. The prototypes exist. We're just at the early stage of a biological computing revolution. The challenges ahead before we all rush to buy bio laptops. Let's be real. Containment. We're dealing with living organisms. How do we prevent accidental spread? Ethics. Should we engineer life forms for computation? Speed. Biological operations are slower than silicon, at least for now. Researchers are working on safe, contained systems and hybrid models to combine the best of both worlds. Show real demos. Part 2. In this part of the video, visuals could include scientists modifying bacterial DNA using CRISPR. Simulations of DNA storage compared to silicon storage, concept animations of bacterial nanoprocessors powering AI systems. Why this matters for you if you're a tech professional. Start learning about synthetic biology, DNA storage technology, bioinformatics. If you're a student or enthusiast, the future of computing may not be in a coding bootcamp but in a biology lab. And for everyday users, this could mean faster, cheaper, eco-friendly computing for everyone. Call to action CTA. What do you think? Would you trust a bacteria-powered computer sitting on your desk? Drop your thoughts in the comments section. If you found this video useful, hit the like button, share it with your friends, and subscribe to the Christian Omeni Tech channel for more future-ready tech insights. I hope this video has been informative for you, and I want to thank you for viewing. Please subscribe to our YouTube channel for more content.